Hello, knowledge seekers. Let's continue our journey to learn Agentic AI. We started with the fundamentals, and let's first understand one use case on the usage of Agentic AI. So, the use case which we are taking today is uh, use of Agentic AI to generate the SQL queries and uh, writing questions in the form of natural language and getting the information from the database. Uh, so, uh, so the user can ask how many employees joined last week, how many employees joined in last 1 year, or a complex query like which is a mix of pulling the information from sales and marketing, which are different departments or finance departments, or within the same department based on regional sales or the national sales or the global sales. Okay. Uh, So how to create a multi-agent pipeline for a complex solution. So in a simple solution, you ask a simple SQL query question like how many employees joined last week, or a complex query like getting the marketing and sales data to get the insights. So we can use agentic workflow solutions. It can be implemented using uh, a lang graph in uh, or if you are implementing on AWS, we can create step functions or state machines to create the workflow. So the first workflow required is the planner agent. So whenever any query input query comes, it will analyze it and divide into multiple tasks, and accordingly the next agent will create the SQL queries, and then there will be another agent to get the information from the database and compile the answer, and finally a reflector agent will check if there is any error in the query, or the output is as desired, or needs to create the query again and ask the data, request the database to provide the response. In addition to it, if you have come across Georgia law, California law, or European law on data security and data privacy, the security data privacies can be done using tools, frameworks like Privacera, Ranger, or Protegrity. Uh, Policies can be defined on the base of the uh, organization hierarchy and the location from where the person is accessing data, and what permissions the user has. Based on the uh, private information or the personal PIP information, the columns can be masked from sharing to the user. So like if in a hybrid interaction model where it's not about just asking queries, but in the form of natural language asking questions and requesting the agent to update the information. So in that case, uh, for any insert, update, delete, or CRUD operations, API endpoints are used by the agents instead of directly writing the queries uh, for the data security, and to keep track of data lineage governance, so that auditing can be done. So let's dive into the use case of bridging natural language for enterprise SQL. So here is a simple agent which has been like uh, for a simple solution to write SQL natural language and get the convert to SQL query to get the desired output. So for learning purpose in NA10 kind of platform, you can create such prompt. It just says you are an expert SQL analyst for a human resource department. So here the persona is SQL analyst. Your role is to accurately translate plain language requests into efficient SQL queries for a database schema that is provided below. So the task has been defined here. The tone has been defined. The format has been given in which the output should be given by this agent, and the entire metadata has been uh, provided for the HR system into the agent. In a real-time scenario, one can use a retrieval augmented generation knowledge base to store the metadata about the solution, or the from which user will interface and get the information. Okay, so what kind of challenges one faces when we are conversing to get a database to have interaction with the database? So database, the natural language is ambiguous, and data schemas are obsolete and rigid. So we define the tables, columns. So how to make agent understand the semantic data about the database, about the tables and the columns, is like by providing all the information in the knowledge base. So when we mention about database, what is the purpose of database, what that database does. Similarly, for each and every table, in a simple natural language, provide the information about the table, about each columns, and the relationship between different tables and columns. Similarly, to provide the semantic information, the additional information can be given in the knowledge base on how the company specific uh, uh, a way of showing the revenues, or calculation of the weekly, monthly, half yearly, yearly, and so on, for calculation of the revenues. So there are three steps in which this grounding is done, which acts as a global positioning system for the agent to understand the database. So very first step is the structural schema, which is providing the database table column information. The next level is uh, reading information for the current requirement, and third is getting the semantic metadata information. So in three layers, the agentic solution can get the information to provide the to create a query and get the desired output. So in a simple work solution, when user writes a query, there will be agent which will convert the text to the SQL, and then it will run the SQL on the database, and it will from the output, then the synthesizer agent will synthesize the output, and it will be given to the guardrail to check the validity and the tone of the output before sharing it with the user. So so when text to SQL conversion is done and it reaches out the database, it should have access to the database credentials available, and so that the program can agent can interact with the database. So in such so we need to take care of privacy and security here, so that credentials are not leaked, and third party or any spam cannot be able to access the database. So if we implement similar such solution on cloud, we need to make sure that text to SQL agent and the database is inside the private subnet and not the public subnet. So the user query comes from the public subnet into the private subnet, and all the processing is done within the private subnet and the response is given to the user over the public subnet. So in case of complex solutions, if the SQL query is does not give the output, or there is a error in the SQL query, or it returns null, In such case, reflector loop agent can be used, which will generate the SQL query, and then it will run the query. It will look into the error. Based on the error, it will analyze and fix the SQL query and run it again. So it will repeatedly do this until the error is resolved, and uh, if after certain cycles error is not resolved, a human loop can be it can intervene and help the user to get the output. So let's consider a complex example where a user asks a question to compare Northeast sales, which is a kind of a regional sales for the last quarter, and it wants to compare it with the sales of the country across all regions. So it's in such a query, it needs to be divided into subtasks. One is to calculate Northeast sales, and then calculate the sales of the entire country from all regions for comparison, right? And then finally compiling the two results and giving the output to the user. So to implement such complex solution, agent should be capable of dividing this multiple task into subtasks and execute each task and then pass on the answers to the next agent to synthesize the output. So let's understand it. So if for such solution, you will need a planner agent, which will be the strategy to decompose the request into multiple subtasks. Then the schema agent, for each subtask, it will extract the SQL query and based on the metadata provided, the table information and the column information. Then the writer agent, which will generate the SQL query. And finally, the reflector agent, which will check if the output was correct, if there was any null error or any other error, to rewrite the query and convey the answer to the guardrail before passing on to the user. So what will the planner agent do? So the planner agent will let's take this example, Northeast sales versus national sales. So first task it will create is get the SQL query for the Northeast. Then the second is get the sales for all the regions, and third is to route the output to the synthesizer, which will do the comparison. So how would a planner agent look like? To deconstruct complex business logic into atomic data retrieval steps. So before we do a separate class on prompt engineering, here is a kind of a live example to learn the prompt engineering. So prompt engineering has 6 ingredients: persona, task, tone, exemplar, format, and context. So in this system prompt, you are a senior data architect. Your job is to decompose a complex natural language user query into a sequence of a logical subtask. So this is a persona and the task given to that persona. So what are the instructions given to the prompt is identify all required metrics, identify all filters, break the query, the output should be given in which format, and the example of the output format. So once the queries are broken down, then the next is the schema agent. So what is the role of the schema agent? So it will discover identify the domain of the subtask and fetch only the relevant table definition, right? So if there is one query from the sales, it will find out this query is from sales, or the second task, which is this query from the marketing. Accordingly, it will find out the information of the database for that particular system. So a enterprise company will have a inventory, HR information, sales. There are different third-party tools used like Concur. Accordingly, it will have interface and the metadata about all the systems, and it will, based on the question, it will only get the relevant information, so that in an optimized time and frame, the agent is a solution is able to give the output. So let's understand an example prompt for a simple context agent. So the prevent token blot by selecting only relevant schema fragments, right? Tokens are costlier, so to get instead of passing the entire database, we get the relevant information. You are a metadata librarian. Given a subtask, your goal is to identify the minimum necessary tables and columns required. So this agent should have interface to the knowledge base where all the metadata is saved. Okay, so the input given is high level table user subtask, so that it can so this information it will collect from the knowledge base. And then the instructions, so you can pause and read the instructions. The text to SQL agent, retrieval augmented generation, right? So the job of this agent is to convert the text and the metadata given to SQL, use it to create the SQL query. Right. So here it will also have access to a knowledge base to the format in which date is used, like in British or India, the format is different from the format used in America. So such information can be provided in the regional settings if it's a cloud solution which is globally providing the services. So let's see how the prompt for a SQL agent would look like. Generate syntactically and semantically accurate SQL using verified snippets. So what is the persona used here? You are an expert SQL developer. And what is the task given? Generate a syntactically correct query. So what is the context or the information it will collect from the knowledge base? It is schema examples of the similar queries asked in the past, and goal is to create the subtask. Okay. So based on the subtask, create the SQL query. So finally, the next after all the SQL queries are created, then we need to get the output for all those SQL queries, and then combine that output to be given to the synthesizer. So what will reflector agent do? Before the answer reaches the user, reflector will check whether the output had any exception, does it had any null error, and if there is so, it will again reach out to the SQL agents to with the correct metadata and to correct the SQL queries, and then rerun those SQL queries and verify the output. If after repeated attempts of 3 to 5 attempts, a human intervene agent can be provided so that it can look into the answers given and correct the agents or the metadata information. There's always possibility, like over the period of the year, database are updated, tables are updated, new indexes are added, or the new columns are added. Sometimes indexes are not working, so new index needs to be added. So human intervention, human loop is always a good practice. So how would a reflector agent look like? Analyze execution failures and pivot. The persona here is quality assurance agent, and with specialization in database debugging. So finally, if the SQL, the tasks are from different domains, you need to combine it. You need to compare, like in this case, the query was regional sales, compare with the global sales. The synthesizer agent will combine the output of the two and create the final output. So here I have not included the prompt, but you can try to create your own prompt for the synthesizer agent. So that's an exercise as part of this learning. So now, so far we have only considered where the user is only asking the questions to get the output from the database, but there is always a need of updating the database, doing the transactions. There is a creating new employee record, or deleting an employee who is leaving the company, or updating the new member added in the family, and so on. So which requires CRUD operations. So CRUD operations, there is always possibility that while the transaction is happening, there is some error, or the system goes down and it has to be rolled back. So all such things cannot be done by agent by simply converting text to SQL. Also, with text to SQL queries, there is no auditing possible. So for such solutions, we even need to have a additional agent which will feed the user's information and the transaction it's doing, so that it can be saved into a database. Into the database, and auditing can be done. There can be a lazy loop which can do such things in the background. Yeah. So so in a text to SQL, user query is given, the SQL is generated, and there is only read operation. While in case of CRUD operations, it will go to the API gateway, and API gateway will do the validation, it will do the transaction, and then serve the output through the synthesizer agent and the guardrails. So why we need APIs? We cannot trust on LLM to delete test statement. There are relationships, and certain verification needs to be done before delete, and based on the solution, whether it's a hard delete or a soft delete, some other actions needs to be done. So like before refunding any customer, we need to verify the purchase, we need to verify the bank, do the bank transfer, and do the email notifications. So it cannot be done by agent, and so the APIs are utilized. So like in an agent, we can use tools, APIs, as we use RAG memory, and in the agent we can specify for the such transaction you call the API. Let's understand how to provide the security to the transactions and the information which we access using agents. The constraints can be provided in the form of frameworks like Privacera, Protegrity, and Ranger, based on what kind of database and support tools we are using. Accordingly, we can choose any of these security and privacy frameworks available in the market. Suppose there is a regional sales director, and he does not have access to the global or a country sales, so all such information should be purged from the user. Similarly, if there is a PIP information, that information column should be blocked from the end user, or based on the user having access, accordingly some columns should be blocked. So for such implementation, Privacera, Protegrity or Ranger kind of solutions can be utilized. Okay. So let's understand the auditing and compliance differences between text to SQL and using of API endpoints. So with API endpoints, you can do the auditing and compliance, which a text to SQL cannot be done. So use API endpoints to mitigate the risk of doing the CRUD operations directly using text to SQL. So whenever user input comes, you can use the guardrails and the planner agent to filter the request. So let's see a simple example. Suppose there is a HR system which has different tables, department, jobs, employees, job histories, salaries, dependents. And now a user asks a question: how many employees are in each department? Show the department name and employee count. So this request will go to a guardrail, and then it will check whether the question is related to this solution or something else. Then that after filter, the question will go to the planner agent. Planner agent will divide this question and then give it to the SQL agent. SQL agent will create this SQL query and then get the output from the database, and then send it again to the guardrail and then the synthesizer. One thing I forgot to mention, before it creates a SQL query, it will fetch the other agent will fetch the metadata about departments excuse me, and the employees before generating and then giving that information, metadata information, to generate the SQL query. So if there is another question, find all employees who were hired in 2024 and works in the sales department. So in this case, it has to utilize employees and the department tables and the relationship between that. Accordingly, it generates a query with a join. So what does guardrails do? So the task of a guardrail is parse request, identify metadata, generate a single SQL query. So do not include any data manipulation language. Provide a brief explanation of logic. Okay. So what guardrail is doing, if there is any insert delete request, it will filter it and it will respond to the user that this system can handle such request or cannot handle. So this is the future of data interaction, from a rigid to a fluid solution. Otherwise, if a user has any dynamic information to be captured, it has to be dependent on the DBA to create the SQL query and then get the output and then share it. So that long time period is cut short, and a user can ask such questions, and Agentic workflow solution can convert into a SQL query and give the output. So I have not included quiz here. I have put the quiz on the LinkedIn blog. So please go to the LinkedIn blog and look at the quiz. I thank you for your time. Do give your feedback, suggestions, and continue your learning.